All right. So like I was saying, empirical formula is your lowest whole number ratio of atoms in a compound. So it's your simplest formula. All right. So when you get to AP year, and actually at the end of this school year, I'm going to be expecting this too from you. You do not need to write this down, so just kind of watch. We would give you something like, we would say, you have some sort of a fuel coming out of, that's an X. You have some sort of a fuel coming out of your Bunsen burner, and it's setting on fire in a bunch of oxygen, right, in the room. What kind of reaction is this, by the way? Combustion, good. So what are my products always? Carbon dioxide and water, good. Okay. So what we would ask you guys is we would say, so you have some sort of a fuel. We have no idea what that fuel is, but we're combusting it, and you're making about 70 grams of darn you. Okay. Well, I just need to be able to put my hand on my iPad. All right. So you have like 70 grams of this guy, and you'll get 100 grams of water, right? And from that, you're going to be able to figure out what my fuel is. Kind of crazy, right? So what you're doing is you're assuming all of this carbon is becoming carbon dioxide, all of this hydrogen is becoming water, and then the oxygen kind of gets split between the two. And you're able to come up with that fuel, okay? So what you're doing is you're taking the ratios of how much is forming over here, and you're able to figure out what that original reactant was, okay? So it's kind of cool. You guys won't be there yet, but what this whole thing with empirical and molecular formulas is about is that it's all about ratios, all right? So when you go to do it yourself, you guys are going to be given something more like, hey, you have this mystery compound, which is about 40% carbon and 50% hydrogen and 10% oxygen, right? So I'm giving you a bunch of percentages. Your first thing that you're going to do is you're going to change all of your little percentages to grams. That's what you're writing, by the way. Write that down. I'll change it back to black, sorry. So you're changing all of your little percentages to grams, and that's because you're taking, what assumption are you making about your sample size? If you just change the percentage straight to grams, what's your total sample size that you're assuming? 100, exactly, all right? So you're able to do that because it's all about ratios. All right, so once you've changed that percent to grams, or get grams of each element, sometimes we give you other pieces of information, okay? You're now going to find the moles of each element, which you should know how to do because this is just a conversion, right? So we have a grams to moles, which is just going to be you start with your grams, you make your railroad tracks, we bring words down to the right, and you have moles on top, right? So what number is going right here? Yes, your molar mass. Exactly. All right. So this is one that you guys already learned. Should be pretty easy. So it's a division. You're dividing it by its molar mass if you just want to do it really quickly. Okay? All right. Then you're going to compare moles. And you're going to divide the moles, all of them, by the smallest. Okay, and I know that sounds kind of crazy, but I'll show you what I mean by that. But when you divide by the smallest, you're assuming this guy will be, the smallest one is 1, and you're comparing everything relative to that 1. So that's your ratios, right? So it's like a 2-to-1 ratio or a 3-to-1 ratio. Okay, you have to have a 1 somewhere in there so you know what you're doing. Okay? You do need whole numbers, all right? And that's the tricky part. And especially for pre-AP, that's what we're going to be putting you guys through a little bit. All right? So if you need a whole number, sometimes you're going to get weird decimals. Let me move this up just a little bit. Okay? You're going to get weird decimals. If you get something like 0.01, what would you most likely round that down to? I'm sorry. If you have 1.01, what would you round that down to? 1, right? Okay, so that's easy. That's not one that we're worried about. However, if I get something like 1.3, what would you do with that? You can't leave it, because these things are becoming your subscripts, right? We've never seen decimals in subscripts. You can't round down. So your rule that I need you guys to all write on your paper is don't round drastically, okay? So what do? I'll tell you. All right. This says drastically, by the way, right here.
So we can only round like thousands place.
Right. All right. So 1.3 you would multiply the whole thing by 3. So all of your numbers, you were going to multiply by 3. And that would change it to be like something like 3.9, right? You guys see that? Okay, yeah, so now that's more roundable, right? If you have something like a 1.5 or a 2.5 or a 3.5, you'll get random numbers. What do you think you're going to multiply that one by? Not 5. 2. Thank you. So anytime you have 0.5s, you're going to round those guys by 2. Okay? And then when you get 0.6s, those show up once in a while. You cannot just round those by, you can't round those up either. Those you're going to also multiply by 3. And then you get something like a 1.8, right?
So
or
if it's 0.6 or 1.3, you multiply by 3?
Yeah.
But if it's 1.5, you multiply by 2.
Right.
How do you know
You're trying to get to a whole number. Does that make sense? What? How do you know what? Hold on. What was her question? What was your question?
How do you know, like, which number to multiply it by?
That I'm giving them to you. Those are the only 3 you're probably going to get. If you get another one, you're more than welcome to call me over.
We'll only get like 0.3, 0.6, and 0.5.
Yeah, you'll see it. So if you get something like 1.27, that's really close to 1.3. Multiply it by 3.
Yeah.
Right? Okay. So these are just general rules. There was another question over here. Did I answer it?
Yeah, I just
You're
asked
good?
what about 7, but you kind of answered it. Probably would get
That one, yeah, it'd be pretty close to 1 point, or it'd be close to 3 again, because that would get you a 0.1. So anywhere that you can round, not drastically. Yes, get close to a whole number. Yes.
So when we multiply the 1.3 times 3, we'd get like 3.9, right?
Yes.
Would we round it to 4?
Yes.
Trying to get to
Yes.
the number? Okay.
Yep. Perfect.
Where do we get, so we can just add that 3 in from nowhere?
Yep. You're gonna multiply everybody by it though.
Okay.
Yeah. So to keep your ratio even. All right. Cool. So let me give you an example of that. Number 1 is a really bad example of it. So we're gonna go right down to number 2. Okay, because then you'll see what I mean by the multiplying thing, and I think that's what you guys are freaking out about. So, so finding the empirical formula for a sample of something that has 25.9% nitrogen and 74.1% oxygen. All right, so your first step, according to our little rules up there, is we get rid of these and we change them all to grams, right? No percentages, just grams. We're assuming 100 grams sample. Okay, so that's your first step. All right, your second step. What's your second step?
Down to the right.
Find moles of the
Yes.
element.
Find the moles. So we're going to start with moving our stuff down to the right. We're going to put grams of nitrogen, okay? And we want moles of nitrogen. So,
1 mole and then put the grams of it?
yep. So what's the mass of nitrogen, you guys?
14.000.
14.0.
So we're going to say 14.01.
Yeah.
There we go. Okay? All right? And before we start calculating, I'm going to split the room in half so we don't have to take so much time. Let's do the oxygen one too. Let's set that one up. So we're going to have 1 mole of oxygen is about 16.00 grams of oxygen. Okay? So this side of the room, you guys knock out oxygen. That side of the room, you guys knock out nitrogen.
So the oxygen.
Okay? Yeah, you guys do oxygen, and then once you have an answer, you can shout it out, and I'll get a second on it, and then we'll move on. Okay?
Isn't it 400? No.
It's not 400, it should be smaller.
And then you multiply that by.
Does it divide it?
All right, so I'm hearing for oxygen a 4.6.
But we have to
6.3?
multiply it.
4.63.
No. That's not the step to do it on. Okay, so 4.63, and you guys are good with that? Okay, so we got 4.63 for our oxygen. Hold on. This is taking me forever to write. All right, what did we get for nitrogen? 1.85? Everybody? Okay. 1.85 moles. All right, now what's my next step? Divide them all by the smallest, right? Now you divide by the smallest. You do not round at this step. That's the biggest mistake everybody makes. So we're going to divide both of them by this 1.85, who's the smallest. Okay? I apologize. I did not realize how bad blue looks up there. I'll write in black. All right, so then your fourth step is we're going to write that number out. So 1.85 divided by itself. We get a 1. You should always have a 1. And this one down here, you gotta, what do you get? 2.5. Good. All right. So here's your example. This is what you need to look at. This is where you would originally put in your subscripts. But we've never seen a 2.5 as a subscript. This is where you do that multiply thing. So we're going to multiply both of them by 2 to get rid of the 0.5.
That'd be 5, right? Is that 5?
Yep. Okay. We're going to multiply both of them by 2. So then you're left with 2, and this guy is a 5. So you have N2O5. And that's it.
That's true.
And that's your empirical formula. Okay? Cool? Not too bad, right? All right. So would you guys like me to run through one more?
Yes.
Together? Okay. So let's go ahead and look up at the top one. The top one is a little boring, so unfortunately it won't give you the same thing. But we'll run through all the steps. Okay? So the first thing is we change all of these guys to grams. Okay? And then we're going to change them to moles. That's your second step. Yep. So zoom in so I can write. Okay, what's molar mass of Fe again? It's 55.845, so we're going to round up to 8.5. That's bad. But that's an 8. I'll rewrite it. Okay, and then sulfur is 1 mole and 32.07. Okay, so I heard somebody shouting out the Fe one. What is it? No, nobody did? Okay. 1.14, okay. So we have 1.14 moles on this guy. What are we getting for sulfur?
Sulfur is 32 point.
We already got that. We're trying to get our moles. You're good. You're good. 1 point what? Yeah, they're the same, right? So 1.14. That's why I didn't want to use this one as our example. All right, so 1.14, 1.14. So do we really have to divide by the smallest? No, but let's just do it just so you have it in your notes. So we would divide them both by themselves, which would give us both 1 and a 1. No special multiplying rules. Your answer is just straight up, yep, FEO. FEO. S, yes. Now I see what you're saying, sorry. Okay. All right. And just kind of like what we were saying last period, you can always check yourself, especially for the ones that you guys are learning on. Most of them are ionic compounds. You can do that reverse crisscross, and you'd actually check yourself out. And they're both accurate, so we're good. Oh, I guess not the N2O5 one. All right, so there you go. All right, so what I want you guys to do is turn this page over. I want you to do one on your own. Okay? Your true formula. All right, so we're going to write true right in here. All right, so this is your true formula. So if we were referring back to that problem that I kind of described to you earlier, where you found the empirical formula or the ratio of these things, I could then turn around and tell you, actually, the molar mass of that substance is 550. Okay, you could use that as well as the ratio formula to figure out what the actual formula is. So that's what you're going to end up doing. But that's where this would apply. Okay, so your steps for finding your molecular formula is first you always start off with finding your empirical formula. So you guys being pre-AP have to be ready to find your empirical formula and then turn around and find the molecular. All right, you guys are multi-step capable, so you guys have to be ready for that. All right. So when you find your empirical formula, you're then going to find your empirical formula mass. And you're going to do that by adding up all your periodic table numbers, right? So you're going to get your molar mass for this. Once you have that mass, you're going to divide the molecular mass by the empirical mass. Okay? So you're going to... When you divide them, you will get a whole number. So if you do not get a whole number, you are probably not doing it right, okay? Because this is a ratio. You're seeing how they relate to each other, all right? All right, so if you get a decimal, you probably swapped them. Then your final step is going to be you're going to multiply this ratio by all the subscripts, okay? So you're going to multiply each subscript by the answer from step 3. All right, so I would say it gets a little confusing with all these words. So your little shortcut here, okay, your little cheat method that you guys can remember is that your molecular formula mass is always going to be the bigger number. And your empirical formula mass is always going to be a smaller number. Okay, which tells you, once you guys are dividing that you will get a whole number ratio, right? If you get a decimal, if you get 0.5, you did it backwards, right? Okay. And then, like this little picture shows you, you're just going to distribute that ratio between everybody inside of that formula. So it's not too bad. It's pretty easy. I would say the hardest part is making sure you get the empirical formula right in order to get this guy, okay? All right. So let's try out this first one. So we have the empirical formula for ethylene is CH2. Find the molecular formula if the molecular mass is 42.09 grams per mole. So the first thing that we're going to start off with is we have an empirical formula, right? What's your second step? Right, we need to find the empirical formula mass. Okay, so we have CH2, so I'm going to refer to my little periodic table and I'm going to say carbon is 12.01. That is really ugly. I'm going to go back, sorry. All right, so we have 12.01 plus hydrogen, which is 1.01 times 2. You should be getting around 14.03. Okay? Do you see that this number is smaller than the one they gave you? You see that? So that's where you can use that little shortcut. Okay? Just recognizing that it's smaller, he goes underneath. Okay? All right, so your third step is the division. Okay, so you're going to do your molecular formula mass divided by your empirical formula, or big number over small number. So I'm going to say 42.09 divided by 14.03. Okay? Go ahead and plug that in so you can see it for yourself what kind of number you should be getting. Once you've got it, you can say it out loud and we'll second it.
C3.
No, what's the number that you got right here? You got 3, right? You got a whole number. That's what you want, all right? So the last step is telling you, I'm going to have to write it up here, sorry, is we're going to take that CH2 and we're going to apply that 3 to it all, all right? So you're going to go to this one and to this one, and you're going to end up with C3H6, and that's your molecular formula. So please notice this one can be simplified, but you don't want to. You need to leave it alone. That's the molecular formula. That's the true formula. There are 3 carbons and 6 hydrogens that make up that molecule. Okay? So that's your true formula. All right. Let me run through the last one before you guys leave. So we've got butane. Okay? They gave you an empirical formula. So your next step is find your empirical formula mass. Okay, so if we have 2 carbons, I'm going to say 12.01 times 2. Sorry, I should have brackets around that. Plus 1.01 times 5. Okay, and you guys would get 29.07 grams. Okay. What's your next step? You do big number over small number, or molecular over empirical. Okay, so we're going to say 58.140 divided by 29.07, and you get what number? 2, right? You could actually do that one in your head. This is about 60 and this one is about 30. So you could have kind of looked at that and done it in your head. All right, so once you have 2, we're going to multiply 2 by all the subscripts. We get C4H10 and you're done. Okay? All right, so that's it.